it's a reality, is that if you want to have a great job, you've got to be able to think mathematically. You have to be.
To all of the maths teachers out there,
Yep.
and to the students in maths classrooms doing the maths, maybe who haven't tasted what you're talking about,
Yeah.
for which it's almost the kind of stuff you've been doing is another language. What would you say to them, to teachers and to those students in, for 10, 11 years, students have to do maths in this country.
Yeah.
And so they're there and they're doing it. So what would you say to those two groups of people?
We have to do math.
They do.
You have to do it.
That's right.
It's get out there and make mistakes. Make things interesting for yourself. Discover. I think part of the thing with maths as well is the fact that we get told so much, but it's better to kind of try things out and be willing to fail. And also, I have no qualms whatsoever to try something and fail in front of a class, and that's something very hard because as a teacher you will get questions like, "Don't you know that? Oh, I thought you were good," and people.
Aren't you the teacher?
Yeah, exactly. Yeah. But I think it's fine to fail because that's everyone does. It's hard stuff. Maths is really hard. It's something that is super recent. Like we have evolved. Our brains are so amazing. And we've evolved these senses, and it's like for example, if we, you read English and we speak English and you'll see a word, you cannot not see that word. It's impossible.
It's imprinted into your mind.
Yeah, it's imprinted, and that's our brains. We are pattern seekers, and the patterns we seek, they're so strong. It's because our brain is geared towards it. And in mathematics, we are looking for these patterns that are abstract. So there is this kind of this great pleasure you can get out of it. Just like when you see something there with those magic eyes. You remember those ones where it was like,
you got to sort of not focus.
Yeah, you have to not focus,
the
and
3D
something comes up.
Yeah.
Or even like an ink blot thing or whatever. But yeah, there's these there are these great patterns that you can discover, and it is really enjoyable to kind of get it. But you kind of have to really. It's sort of like learning formulas, memorizing formulas. I mean, I know why that's so hard. The idea that the easiest way is just memorization is a fallacy. It's the easiest way is understanding. Understanding it is being lazy.
Work out why.
Understanding
it all
something,
fits together,
yeah.
That's your quickest path, really.
Yeah, and that's right, it is. And also, you're equipped. So, for example, like all those trig functions, those trig functions like 2 sine cos equals sine 2 theta.
All the expansions,
all those expansions, yeah. So I just learned that was like e to the I theta equals cos I sine theta, and that's all I needed to know, because like in an exam I would just write it out. So I basically expand the brackets and
you can get everything else you need.
And you get everything I needed out of it. But it was just the idea, and it's like I just knew it, because it's like even if I couldn't remember if it was cos or sine, I could draw the circle and I knew where that was, and I knew this and I knew, and so it was like, for me, it's like I had babushka dolls of like how things would go and how to put things together, and I just thought everyone did that, but it's not true. Like I've seen kids try and solve problems who are like got everything going for them. It's like they're willing to do it, but there's this thing of like, just tell me how to do it. Just tell me.
That's all I want.
Just tell me what to do, and I'm going to learn that. And it's like, that's not how it works, guys. You don't. And you know what? That's any other part of your life. You really wouldn't want that to be the case.
That's right.
We need to have that sense of freedom, and this is intellectual freedom we're talking about. Like, understand it. Just understand it. And the benefits for it are, they're poorly understood, but the benefits are, you will know how to think. And I think there is no one in Australia who is going to stand up and say, I'm illiterate and I'm proud of it. But you'll have people go, I am innumerate, don't talk to me about maths.
I've always been bad at maths. Yeah.
It's shocking. Because who's going to stand up and say, I can't read and write? I mean, there's a great deal of shame involved in that, if people are in that situation. But we're just happy to be innumerate, because we think, we've got computers. So what? So what, we got computers? this actually happened, and sorry, I didn't give you a very concise answer.
It's all right.
But no, this actually happened when I was first starting at Foster's. We had this thing where there's this thing called price elasticity. Have you heard of this concept?
Yeah, vaguely. Yeah.
So price elasticity is you take a certain product, the price it's sold at affects its volume. They're called price sensitive. So think like toilet paper, price sensitive.
You charge more for it.
Yeah,
And people
people would
buy
yeah.
it, yeah.
But then if you're talking about an iPhone, you can charge whatever you want. People are going to buy it. And so you know what I mean. It's like it's that idea of branding. So if the brand itself is so valuable, people are willing to pay whatever the price. So the curve looks like this, right? So price elasticity. So if something is called elastic, which means it moves with the price, it has this curve. It looks like a slippery dip. And so anyway, so when I started working at Foster's Wine Estates, it was like they wanted to bring this in, and they had the maths guy, and it's they were going to spend $250,000 on a piece of software to add on, which would crank this.
To work out exactly
Price elasticity.
what price point we should, that kind of thing. Yep.
Yeah, and so I was like, well, we had the data, so I kind of put the data, dropped it in Excel, and what I did was I was trying to work out how to make this make it stick to this formula. It's called linear regression. You have data points scattered and you're trying to find a line that fits it the best way. And it's what you do in physics, and it's the way you sort of, there's a lot of experimental stuff. It's like, what's the formula
You're
for
trying
this?
to get a model that fits the
It's a
data
model, yeah,
that
it's a
you've
model,
got.
but the model is super precise to like infinitely many decimal points. The data is messy. It's all over the place. It's all, So there's all these other factors, but you're trying to find something. So I was trying to find something in this data. Anyway, there was no equation for linear, the regression required, the fitting, it wasn't in Excel. But because I understand maths, I knew the equation was as 1 on ax plus b. It was a 1 on a linear formula. So I knew if I took half of the data and inverted that, I could find a straight line that fitted it, and then I could invert that, and I'd come back, and I basically worked out a way, using the formulas in Excel, how to make this work. And when I did this, it took me an afternoon, and I presented it. And what that meant to the managers was that this guy is spent an afternoon and can save us $250,000. Because it's not just not using the computer, it's the fact that I can think.
You solved that problem. You had
I solved
the
that
skill
problem.
Yeah.
I solved a problem because I knew how to kind of operate the machinery. And it's and what's crazy is like reading about the moonshot. So when they went to the moon and the computers they used there, I mean,
Back in the 60s.
oh man, the computers they used were just so rudimentary. I mean, a clock radio would have more computing power now than what they used for the moon. But they were so smart. They worked those numbers and were able to think of cleverly how to use things, and that was like, because I was so much into space. The Voyager spacecraft that left was fired in 1977 or something. Voyager 2 flew and passed all the major planets in the outer system.
And then it left.
Yeah,
Yep.
that's right. So it was like Jupiter, Saturn, Uranus, Neptune. And when it passed through Saturn, a chunk of rock hit it, and so something stopped working. So its actual arm, it had this maneuverable arm with all these sensors, and it stopped working. So it was disabled. By the time it reached Neptune in '89, because people knew how to program better, it was a smarter spacecraft in 1989 than it was in 1977.
That's incredible.
So it could do more in 1989 than it could do when it was launched and was fully functional.
it was the same piece of hardware.
Of course, no one's gone out. They didn't send anyone out there to go and fix it.
But they've used intelligence to update
That's right.
the way it actually functions.
That's right.
Incredible.
And that's what, I mean, I don't know if this is a motivation, but it's a reality, is that if you want to have a great job, you've got to be able to think mathematically. You have to be. Because, the way that Nokia, for example, when they were first kind of working out, when they reigned the mobile world, when they had the small mobile phones, which we had sore thumbs on, the sending around data that was a super hard problem to solve. And the way they solved it was sending packets Like, it's crazy. The maths is crazy they had to do, but they had to crack these problems. You crack these problems, the rewards are enormous. And Facebook now. Facebook was using the type of maths which at one point no one thought was applicable to anything. So networks and
Graph theory and
graph theory,
connections and
yeah.
all that
So
kind of
Ramsey theory. Actually, there was a number file thing I did about that, talking about what you can infer from clicks and people knowing each other and not knowing each other. But they're crunching a lot of numbers on maths, and they're using it in this really, some say, scary way. But they're using all this knowledge and they're getting stuff out of it.
You can gain insights when you know how to work the data.
Yeah. So there's all this great stuff, and the algorithms they use of what you're seeing, and it's like, why am I seeing this? And they're making decisions based on how you're interacting. All that stuff is mathematical. And so if you really want to differentiate yourself out there, we're in a very unique position in Australia, where we have the opportunity and the space, and thankfully a peaceful society for the most part. You can actually spend time getting this working, and then you can go off around the world. Although it's best to stay here. And
don't take all that intelligence you've developed and leave.
The brain drain,
Bring
but you can go overseas and you can do amazing stuff.